Great. Well, hello and welcome everybody to this workshop on the identification of some common rock forming minerals in hand specimen. Um, the whole idea of these workshops is to give you an idea about identifying or trying to identify some of the more common rock forming minerals. It's always a bit of a debate as to what you've got in a rock specimen. Um, it does it does require that your hand specimens are of a reasonable size so you can see things in them. And before we go on any further, there's some very important terminology that we need to be aware of. The whole question of, well, it might be. Um, this is a very inexact science, trying to identify some of these things in hand specimens. So might be the closest you can get, and dunno is always an option that you might want to fall back on. So reasonable size hand specimens, but you've got to be realistic about this. If you've got a Tady egg, for example, that's probably just a little bit too big to give you a good idea. Although one of the important things to remember is that when you've got a small hand specimen and you see some little tiny black bit that you wonder, what's this black bit? And I've had loads of people come up to me and say exactly that. What's this black bit I've got here? To which I would say, well, how common is this black bit that you've found? And of course, if you've got a big sample and you've only got one tiny little bit of this black thing, then you can get some idea about it being not very significant. Whereas if you've only got a tiny specimen and there's that little black thing in there, then of course that black thing could be quite significant. So there is an issue about the size of the hand specimen that you need to be aware of. During this series of workshops, of which there will be at least 4, I really want to concentrate on igneous rocks, but I will be going into some metamorphic rocks as well near the end of the workshop series. But it's mainly igneous rocks that I want to concentrate on. Right, well, here's a rock. We're looking at a rock. Does it contain minerals? That would be the first question that you'd ask yourself. Well, there's these black bits here. There's a black bit there, and there's some black bits there. And there's also some white bits there and white bits there. So in this rock, which is a hand specimen, there's black and white bits. Now, I've said there we've got 2 types of mineral with a question mark. But what we've been able to do is separate out 2 different things in this rock specimen on the basis of colour. Right, the big question is, and that's why I've got the question mark there, are they minerals? Well, if they're not minerals, what else might they be? Well, they could be fragments, for example, or maybe there's something else. There we go. What's this lump here? It's different color, and we said just now that we can distinguish things by color. But is this a mineral? We don't know. It's a different color at least, so it is something different, but is it a mineral? Right. Minerals we've distinguished by color, but how do we know that they are minerals? How do we recognize what's the crucial property? What are the crucial properties that allow us to recognize these things as actual minerals? Let's go back to this picture. It's a slightly enlarged version of the thing we were looking at earlier. And well, I can tell you now, there are minerals in this rock specimen, and it is these qualities that allow us to determine the fact that we are looking at minerals. Straight edges, for example. Look, there's a straight edge down there. There's a straight edge here. There's a little bit of a straight, well, look, there's straight edges in there. There's a straight edge there. There's some straight edges here. Angles. Look, we've got angles here. There's an angle there. There's a sort of an angle, possibly there. Just hunting around that. Oh, look, yes, there's some angles there. Regular shapes. Well, look, that's quite a regular shape there. That's possibly a bit of a regular shape. That's a sort of partially regular shape there. This dark bit in there, that's sort of regular. Look, there's an outline there. This bit here is interesting because we've got these things which are over the top, so it's masking it a bit, and that's something you always need to be aware of when you are looking in detail at these rock specimens. So regular shape, and there's also crystal faces. There is a crystal face. There's another crystal face there. Crystal face there. There's a crystal face there. Can't see it too well on that piece. Just hunting around. One of the things when you are looking at these, do take your time. Do spend plenty of time just looking at the detail. And I think I will say later on about not wanting to rush to conclusions, because it's a bit, you know, being painstaking in what you're looking at is very important. And if you've got a reasonable size specimen, like I was talking about just now, is to make sure that what you are looking at is representative of that rock. Like I said, if it's a little tiny black bit and there's only one little black bit, then, well, forget it. We can't get, you know, any much closer than looking at the things that are representative. So that's what we're looking for when we're looking at minerals. Straight edges, angles, regular shape, and crystal faces. That says, right, these are mineral crystals. So minerals are crystal shaped, what we call euhedral. Need to have some terminology when we're talking about these things, but euhedral is a useful term to use. That means crystal shaped. And so minerals, it says there, are euhedral, and they're well formed, sharp crystal faces, etc. Yeah, except when they're not like that. And this brings us to the first point about trying to identify minerals in hand specimen. They don't follow the rules. Whilst many minerals will have a nice crystal shape that you can recognize, some don't. This stuff here, I challenge you to find, well, that might be a straight edge there, but well, we'll look at this on a bigger magnification in a moment. Here, well, look, there's this bit there, and that bit there, and that bit there, and that bit there. So none of these have got any reasonable crystal shape. We call that, well, that's granular habit, or to give it its proper term, anhedral. Anhedral means absence of shape. And some of the minerals that you're going to look at will be anhedral. There are some classic minerals which we're going to learn tonight which do not have a proper crystal shape when we see them in hand specimen. And the sooner we're able to recognize, identify, and push these to the back of our memory, because we know them by that time, the better. So, right, let's carry on with this idea about color. We've used color to distinguish. Yeah, there's that dark stuff and this bright stuff, but can we use color to aid any identification of these minerals? Well, here we've got some black stuff, and here we've got some green stuff, and here we've got some pale, very pale, light colored, bluey, paley blue stuff there. These are all the same class of mineral. And well, maybe color isn't particularly helpful in this instance. here we've got a colourless mineral. There's another bit of colourless mineral there. There's lots of colourless mineral around here. And look, there's lots of colourless mineral here. And there, and there, and there, and there. So in both these rocks, we've got the same colourless appearing mineral, but they are different. Now, just by looking at comparing this darker rock with this lighter rock, you can't tell that this one, that bit there, for example, and that bit aren't the same, but I'm telling you, they are different. So this is going to be a source of confusion until we realize how we're going to deal with this. I want to carry on with this idea about color because it's probably one of the first things we identify when we look at rocks in hand specimen. The colors leap out at us. But using color to identify is a completely different ballgame. I want to consider the rock-forming mineral plagioclase. And we're going to deal with plagioclase later on this evening. So plagioclase, it's a major rock-forming mineral. But when we look at the color of plagioclase, well, it can be white, it can be gray, it can be sea green, it can be brown, and it can be colorless. So there's a whole range of colors that plagioclase can take up. And what actually determines basically the color of the plagioclase is how many, well, what sort of trace elements are actually included in the crystal structure, because often it is tiny amounts of another atom, another element, another chemical element that causes the color rather than the main mineral structure. And this is going to throw us off our identification unless we're really careful about this. Right, so continuing with our colors, well, olivine, well, that's classically olive green, except when it isn't. Often it's green, but it can be gray as well. So color on its own is not a reliable way to identify minerals. It can be a help, and as we'll see later on, it can be a significant help, but on its own, it's not a reliable way to do it. So you're looking at a hand specimen, color will leap out at you, but you have to be very careful and you've got to be methodical in using a range of other qualities that we're going to be looking at in a moment. Right, let's move on. So that's what I'm saying, color, not a reliable way, and neither is, as it says there, the appearance of the crystals, what we call the crystal habit or the crystal shape. Okay, so if we're saying that we can't use color on its own, we can't use the crystalline appearance on its own, what else can we use? What other properties? Well, we've got this thing here. Is it shiny or isn't it shiny? It's what we call the luster. This will be quite apparent. We'll have a look at some examples of luster in a minute. Is it transparent or not? And it's a property that we call the, I love this term, the diaphaneity. If we can find nice crystals, sometimes their shape can be a good giveaway as to the identity, but not always. This presence of something that we call cleavage. I'll talk about cleavage later on and in more detail in the second of these workshops. Cleavage will be a series of striations, but let's say I'll mention that later on. So those are a series of properties that we can use to help us in our identification, but none of these on their own. So we have to use a combination of properties. And even by using a combination of the observable properties, these qualities, like the crystalline nature, the color, the crystal habit, the shape, the luster, the diaphaneity and the cleavage, those using those combinations will still often only come up with a probable identification of the mineral. You could say, well, it's possibly, or it's likely to be, but like I say, this is not always an exact science. And often the other thing we need to be doing is looking at the association. And what I mean by that is we're looking at a particular mineral. What is around that mineral? Can the other things around that particular mineral that we're looking at give us a clue to the identification of the mineral we're looking at? And so all these aspects we need to consider. And as I say, I keep on trying to hammer home this message about being methodical, going through all these, almost like a checklist, going through all these properties and coming up with your identification. Right, let's carry on. As it says there, don't jump to conclusions, be methodical. And it's important to realize that there's often, you're going to have things that will fit into this, I don't know, I haven't the faintest idea. So you can't always be complete. You can't do it all the time. And there'll be things that you just don't know what they are. That's the way it is. But you've got to be aware of that. So don't always strive for perfection. You'll get partly there. And that's really where we want to be. Right, let's go back to this lovely granular anhedral textured mineral. Right, now we're looking at this in detail now. So here's your scale bar there. So this granular material is a couple of millimeters. If you're looking at stuff around a couple of millimeters or more, obviously you're going to need some assistance, and the hand lens is obviously the thing to be using when you're doing this. You can't easily start doing this without using a hand lens. So make sure when you're trying to identify your minerals, you've got your hand lens with you. Right, let's look at this stuff here. I said that I couldn't find any real crystal. I don't know what that there is. That's possibly something. Maybe that, possibly something there, not very well defined, but the majority of the stuff is like that. It's all this granular, shapeless, not what you'd call a proper crystal shape. It's all granular. But in this specimen here, it's the color that is the significant thing. It's this sort of greenish color that is coming out at you. Right, let's carry on. Slightly bigger magnification of one that we've seen earlier. There's your scale bar. Here we go. We've got that stuff there. Again, this is 2 to 3 millimeters size of these, some of these granular bits. All that there, hunting around there, possibly there. There's some there, that stuff there, a bit there. And what we're looking at here is it's sort of, it's almost colorless, but there's a slight hint of gray about it. Now this might be because we're looking at a transparent mineral possibly, and there's stuff behind that is sort of slightly giving a slight color. But there's lots of this granular material around there. Nothing that I can see there with a good crystal shape. Right. This is the one we looked at first, the green. And let's now go through the detail of the properties using that almost a checklist that I gave you earlier. Right. First property, granular appearance. Yes, it's anhedral. We've gone through that now, so it's anhedral. Most of this is mainly clear, transparent. Looking at it with a hand lens, it will be pretty transparent. It's glossy, shiny. It looks like green broken glass, broken bottle glass, green. And it's got this olive green color. And as it says there, it is never as a crystalline form. And this is the mineral olivine. So if you've got in a hand specimen some stuff that is granular, nicely granular like that, and it's this green color, and it's glossy, it's mainly transparent, and it looks a bit like broken glass with a green color, then you've got olivine. But remember, I said you could also have olivine looking like this, except that it's more gray colored rather than green. And it can also sometimes be somewhat more orange than green. Not so common, but mainly the color is green, is this olive green, but it can be more gray, and it can also more rarely be slightly more orange in color. But if you've got stuff like that, then you've identified olivine. So this is the first checklist to remember in terms of how to identify olivine. Right, so the other bit that we were looking at, the other sample with this granular, slightly grayish, but mainly colorless material. Well, let's go through the checklist. It's granular appearance, so it's, as it says there, never crystal, so it's anhedral. It's clear, transparent, mainly transparent. It's glossy. It's like broken glass, only this time it's clear broken glass, colorless. And that is the mineral quartz. Now, from this point, if we had this material here in its gray form, it could very well look somewhat like this. So that's one thing to be slightly aware of, and we'll come on to this in a moment or two, about how to distinguish and how not to confuse. But like I say, a large proportion of the time, your olivine will look like this and your quartz will look like that. So what we've got here are the two important minerals to be able to identify that will not have, generally speaking, a good crystal structure. But there are some cases where, and these are exceptional cases, you're not likely to come across these very often, but under some conditions, rarely, your quartz will have crystal shape, and it will look like this. It will have these sort of cavities, and there's your scale bar there. So we're talking about these crystals here, slightly more well, slightly less transparent, but this sample has been somewhat weathered, which is something to be aware of. Weathering will alter the transparent nature of some of your crystals, so that's something you need to bear in mind. But the shapes of these things, you've got terminations here. See these pointed terminations in this sort of slightly whitish material. There's another piece there. There's a big piece there. It's getting on for 5-7 millimeters, that length there. And there's pieces here. So these are all quartz crystals, but they occur in what we call druzy cavities. And this forms as a result of a large amount of water in the crystallizing magma. It's not a very common occurrence, but I'm putting it in here to show you that you do need to be aware of these sort of things. Most of the time, your quartz will be granular and anhedral, but occasionally, rarely, you've got euhedral quartz if you've got these particular conditions where the magma is water rich and you're crystallizing large crystals. The reason you don't get good crystals forming in the normal quartz is that by the time the quartz is crystallizing out at a temperature of around 650, all the other minerals have taken up the space, and so there isn't really much room for your quartz to grow into nice big crystals. And also it's at the very end of its crystallization process, so there isn't much time either. This stuff that we're looking at here in the Druzy granite forms because the crystallization process is enhanced by the large amount of water in the magma. So you have to have a water-rich magma which allows rapid crystallization and big crystals to form before you get anything like this. Now, just one other thing I want to point out while we've got this sample here. We've got just up here, this grey, that's got a termination on it. That piece there, that's some of the grey material there. That's a piece there. And there's some in there, just in there, that little bit in there, and there's a termination on that. This is a different type of quartz. This is a cairngorm quartz, what we call a smoky quartz. So just a slightly different type, but the crystal shape, which is characteristic of SiO2 crystals, quartz crystals, the crystal shape is the same. So this is one example where it's an exception to that rule. And here's another one. There's a scale bar down there. This is something called a granophyre. And again, this is a water-rich magma crystallizing quite rapidly, allowing crystals to grow very big because of the amount of water in the magma. And here we've got 3 millimeter or so crystals of quartz. Again, this is more clear than the previous mineral sample I've just shown you. So this is much less weathered. So we've got these clear, good crystal shaped quartzes in here. There's some slightly more weathered ones there. I've got that more whitish color. There's some more, I did see some, oh, there's one there. There we go. It's a little one there, possibly a little one there. There's one down there. There's one there, there. And the more you look at these, I think that's one there, more you look at the sample, the more you can see examples of these good, that's possibly one there as well, which is bearing out what I said earlier on about taking your time to go and look at these. There's another one in there. So you do need to spend time just looking over your sample, not, of course, jumping to conclusions. There's one there as well. And one there. So these are the exceptions. And the likelihood of finding these, well, they do happen, and be aware that they do happen, but not so commonly. Right, okay, where are we so far? Well, we can identify quartz. Quartz is granular. Olivine is granular. These are anhedral minerals. And as I say, remember that there are exceptions. Sometimes you can find good examples of quartz, and similarly, you can, under some conditions, find good examples of olivine crystals in your rock specimen. But predominantly, they will be that anhedral habit. Now, if we can manage to identify either quartz or olivine in a rock, it's really good, because what it does is place the rocks, those containing olivine and those containing quartz, into two very separate parts of the igneous rock spectrum, as it says down here. If we've got olivine, it says that the rock we're looking at is one of the mafic rocks, or even ultramafic rocks. And if we've got quartz, we've identified quartz in the rock, then it's a felsic rock and it's a granite, or one of the varieties of granite. So being able to identify quartz and or olivine, very, very useful things, because we've now separated out these igneous rocks into these two, well, they're two different ends of our igneous rock spectrum. Right, let's carry on. We're getting on quite well here. Quartz, olivine, nice things to be able to identify. Right, here we've got a colourless anhedral mineral. Well, we know how to do this now. There's a colourless anhedral mineral. There's another one there. Oh, look, there's another one there. And there's lots of them here. There's one there, there's one there, there's one there. So we're now getting quite adept at being able to identify quartz in these rock specimens. And it's all practice. The more you do this, the easier it gets. You begin to say, oh yeah, that's quartz. Oh yeah, yeah, look, there's quartz. So nice colourless anhedral minerals. However, the top left sample that I looked at just now and I was showing you, this is a bigger picture of it. And that nice anhedral material here that I was pointing out, and the anhedral material in here, and where is it down there? There's some anhedral material there. That has the same appearance, exactly the same appearance as this stuff that's got the blue arrows on it, there and there. And here, the blue arrows are pointing to stuff which is euhedral. It's got crystal shape. And there's another bit I've just seen down there, and there's another bit down there. So this stuff that we originally thought was nicely granular and anhedral is exactly the same in this rock sample, exactly the same as this stuff with good crystal shape. So what in actual fact we are looking at these granular bits are simply crystals that haven't had a chance to form properly because of varying constraints. Maybe there isn't a bit of space where that was crystallizing or something along those lines. The important thing is, and the message that I'm trying to get home to you here, is that when you have some doubt, make sure that you're looking at the whole specimen. So the ones with the blue, pale blue arrows, are the crystals that you're looking at here the same as the anhedral material? And if it is, then that anhedral material is this stuff. And what we're actually looking at here, instead of this anhedral material being quartz, this anhedral material is actually anhedral plagioclase. So that's a plagioclase crystal, that's an anhedral bit of plagioclase that hasn't had a chance to properly crystallize. So the message here is, whenever you see anhedral bits, is it all anhedral, or can you link some of the anhedral material with stuff that actually has got some good crystal shape? And that requires you looking over the whole sample. And again, this gets back to what I was saying right at the very start. If you've got a tiny hand specimen, then that representability of your various minerals is not so good as if you've got a big hand specimen. So make sure that you look and you check across the whole sample. And if you have, as in this case, got some material that looks anhedral, but it's actually got the same qualities, the same properties as the stuff that's got good crystal shape, then all you're looking at is material that hasn't had a chance to crystallize properly. And being able to not identify this as quartz is very, very important, because if you identify this as quartz, you would be calling this rock a granite, whereas by identifying it as plagioclase, then well, it's not a granite. So important message there. which we summarize here. The anhedral, colorless and transparent to translucent, possibly white material that's got sort of satiny luster. It's the same appearance as the euhedral, colorless, transparent, translucent, white, blah, 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 which is plagioclase. And so, I've just said is make sure that when you're looking at your hand specimen, and you've got some euhedral examples, check that some of that anhedral stuff isn't really just euhedral stuff that hasn't crystallized properly. And that just being able to distinguish quartz from plagioclase, like I say, is very important, because they can look, well, they can look identical, as we've probably just, hopefully just seen. Right, anhedral granular quartz. Let's go back to looking at granular, really quartz this time. This is a sample that you'll be getting very used to by now. Same one. There we've got the quartz, nicely granular. And there isn't any stuff looking like this that's got good crystal shape. So it's all quartz. And here we've got more granular quartz. Look, there's nice granular quartz there and there and there. There. Excuse me. So granular, glassy looking quartz in two rocks, but this one is an igneous rock and this one is sedimentary. So how do we tell which is which? Well, again, it's checking the rest of the sample. Now, let's take this one, for example. If there are any crystals in this rock that you can identify, well, not identify, recognize, then it has to be an igneous rock. And there are. Look, there, that pinkish colored thing, that is a crystal. There's another one in there. And there's one there, look at that. So these are crystals. So therefore, this stuff in here, this quartz, which we've identified, and we can identify it now, this is quartz, and it is in an igneous rock because these are crystals. However, we can't find any crystals at all. Excuse me. We can't find any crystals at all in this rock. So this is a sediment. So as it says down there, check the associations. This granular anhedral quartz is associated with crystalline material, recognizably crystalline material. Therefore, this is an igneous rock. In this specimen, it is not associated with any identifiably crystalline material, so it is much more likely to be a sediment. The other giveaway for a sediment, remember, these are fragmental rocks. They can have gaps and holes in between the crystal grains, and here we've got holes. So that's the other giveaway for a sedimentary rock. Its fragmental texture is relatively easily identified like that. So checking the associations is important. Now let's carry on. What can we do? Well, we can now identify plagioclase. It's colorless, often, sometimes, transparent, definitely transparent. But if it's weathered, excuse me, if it's weathered, it can be slightly less translucent. It can be slightly white sometimes, but it's got a satin luster and it's got this good crystal shape. And these, what we call lath-shaped crystals, are definitive. Here we've got some lovely crystals in this rock specimen here. It is weathered. Their surface is weathered, so it is masking the translucency of the crystals here. And these are all plagioclase crystals. But the shape is really representative of feldspars in general, not just plagioclase. Alkali feldspars also take up something of this shape as well. So it's that shape which is the giveaway for the feldspars. Let's look at some more examples of plagioclase. Remember that we're looking now for these qualities: colorless, often, sometimes, transparent to translucent, sometimes it's white, it's got this satin luster to it, and it's got good crystal shape. And it's that shape, the crystal habit, that is the nicely definitive guide to plagioclase. Right, here we've got some plagioclase. There we've got a nice crystal there. There we've got a nice formed crystal there. This is a slightly darker one, but it's got stuff behind it which is masking its lighter color. There's a nice one there, just round there. There's one there, that's a nice one there. You see they've got that sort of lath shape. There's this one here that the pointer is sort of sitting over, the arrow is sitting over. There's a nice one there. A nice one I've just seen there, that one there. And this one there. Oh, and there's a lovely one there, that one there. So again, it pays to spend plenty of time looking in detail at what you've got. There's something in there, I'm not sure where that is, but there's something in there anyway. Yeah, we've pointed out that one. So this is plagioclase in a specimen. This is another rock containing plagioclase, and here is the plagioclase in there. There's another one there, but this plagioclase, you'll notice, is slightly more brown in color. There's one there. There's another type here which is much darker there. There's this piece here. There's some brown material there, so that's all plagioclase. There's another piece there. I'm not really sure that it's not such a good shape there, but that big piece there, some of this here. And so that is plagioclase. Another little piece up there, little piece there, and this one here. There's a nice plagioclase in there. There's a nice plagioclase in there. There's some there. We've got a higher magnification of this one, which I'll now go on to. There. There's a plagioclase, light coloured, excuse me. One there, up there. And there's some stuff down there. Bit in there, and a bit in there, and a little bit there, and a little bit there. Now it's important, I'll just introduce this topic. We'll come on to this more in the next edition of this workshop series. But here, well, in the previous one as well to some extent, these crystals are in a ground mass of something which is quite a lot finer grained. So these are what we call phenocrysts. They are bigger crystals in a more finer grained ground mass. The ground mass is fine grained because it's more rapidly cooled. And so these are more volcanic rocks as opposed to plutonic, deeply intruded rocks. And these are, in fact, this one here is a basalt. The other one was a basaltic lava as well. And these phenocrysts would have formed much earlier in the crystallization process and be entrained within the fluid and got caught up in the magma. We'll talk a little bit more about the processes in a later edition of the workshop. But that's why we haven't got a whole mass of crystals in the background. So these are phenocrysts. And the texture, name for the texture of this rock is porphyritic. That gives its name to one of the common names for this type of rock, which is a porphyry. That's one of the names that you could give this sort of rock. But this is mainly a basaltic lava with phenocrysts of plagioclase feldspar in there. So those are feldspars, plagioclase feldspars. And that concludes what we're going to do for this first session. So where have we come from and where have we got to? Well, we now know how to recognize minerals. And there are these things where we've got nice crystal shape, straight lines, edges, crystal faces, for example. We've got a list of diagnostic characteristics, which we've looked at. We've also had some practice recognizing and identifying quartz and olivine. And like I said, being able to identify quartz and olivine, very useful in igneous rocks, because we can put the two rocks into totally different categories of that igneous rock spectrum. And we've learned to identify plagioclase. And crucially, we can tell the difference now between quartz and plagioclase, or at least we've had the training to be able to allow us to tell the difference between quartz and plagioclase. And as I said, that is very important because most of the plagioclase you'll find will be occurring in mafic or ultramafic rocks. You do find plagioclase in the felsic rocks, but it's more common in the mafic to ultramafic rocks. Conversely, quartz you will find in the felsic rocks, in the granites. Now, I was talking about these associations, and what I want to finally mention, and I will come back to this several times during the next couple of workshops in this series, the associations. If you have identified olivine in your rock, you are almost, and I'm thinking here whether I'm going to say never, that's not a satisfactory thing to say, you're very, very unlikely ever to identify quartz in the same rock. Possibly, and I'm thinking here of the lamprifiers, which are quite strange rocks, which will have quartz, and they could possibly have olivine, but I'm not, very, very rarely. And the reason is because olivine and quartz react with each other to produce pyroxene. So it's very unlikely, almost never, will you find olivine and quartz. So if you think you've got both in the rock, you've misidentified one of them, or at least you need to check very carefully on your identifications. Quartz, well, yeah, you can have quartz, you can have, as I say, you will find some plagioclase in some of the felsic rocks, but it's not so common. But that question about olivine and quartz is an important one for you to remember when you're doing your mineral identifications, or trying to do your identifications. I think what we'll do now, as I say, we'll have a few questions. For the next session, we're going to be looking at more light colored minerals. And I'm selecting these on the basis of color because it is this color that leaps out at you when you first look at a rock. So we're going to be doing more light colored minerals in the next session, and that will take place same time next week. So I think we'll now open this up and we will